Hey everyone, today I'm going to be talking to you about the big blue, the big water world that's in our solar system. The water that we can't use. Now, we can't use it because the vast majority of it is either salt, locked up in glaciers, or deep underground. I know, right? The big water world is water useless. Anyway, all right, now let's get more serious. Okay, the big blue. Over 71% of our planet is covered by water. I'm going to be giving you lots of percentages, so follow along, keep up. So 71% of the Earth's surface is covered by water. Of that water, 97% is salt. It's useless to humans. We can't use it for growing crops. We can't drink it to sustain ourselves. We can't use it in our cars, like the radiator. We just really can't use a lot of it. I mean, I guess there are some sources or some reasons why we use salt water that I'm not thinking of right now, but an aquarium, saltwater aquarium. Okay. Anyway, 97% is salt. Well, the 3% that remains, right? Okay, we got 3%, but we can't access the majority of that either. Yeah, out of that 3%, I believe it's like 68% is locked up in glaciers. Let me make sure I'm right. I have some of this stuff pulled up. Uh, yeah, 68% of that 3% freshwater is in ice caps, glaciers. A lot of it, 30% of that 3%, is found underground. I know, right? So 68 plus 30, actually a little bit over 68. So that's like 98%, right? Right? Oh, 2%, not even 2% because these percentages are like 68 point something. I think in total, 1.2% of that 3% we can actually use. It sustains all mammal, bird, animal life on this planet, including the 7 billion people on this planet. So, freshwater is definitely a natural resource that we want to preserve and keep clean and not pollute, not waste, all that great stuff. Because it's such a limited supply and it's got to feed all the animals on the planet, at least the ones on land. So I'm gonna go through this PowerPoint and we're going to touch on some subjects or some topics that were not discussed in the video I shared with you guys, the crash course. All right, so follow along and strap on. So we're going to go through this pretty quick. This is a great picture and showing like the Earth being sucked dry, and that is the 97%. That would be the 3% fresh, and the 1% that we can actually drink is not even pictured because it's so small. All right. All animals, where there are typically water resources, you're going to find animal life because we need it to survive. All life is dependent, that we know of, dependent upon water. See, back in the day, you may have learned that all life is dependent upon the sun. No, it's not. There are creatures underneath the sun, underneath the ocean, that have never seen sunlight. They don't need sun. They get their energy from other sources. A lot of times, they get their energy sources from chemical or heat or chemicals that are released from underwater volcanic activity. So, but we do know that all life that we know of on this planet is dependent upon water at some time in its life. So, it's a very much needed commodity. When we look out in the universe, we want to first see if there is fresh water on the planet to see if there's even a possibility of life. Okay. The glaciers, the 3%, the 3%. Most of it's in glaciers. The 68.7% is in glaciers. 30.1% is underground, and that leaves like 1.2% that we could actually drink. Okay. that's readily available to us, and that's going to be found in streams and creeks and rivers and ponds and lakes, all that great stuff. All right, let's go to the next slide. The water cycle. Yeah, that's just evaporation, condensation, precipitation. Now, there are some words you might not be familiar with, like transpiration. Do you know what transpiration is? All right, transpiration. Let's see if it shows it on here. It should be, well, evapotranspiration. That's basically the trees giving off moisture. The trees breathing basically, and by them breathing, it releases some of the water vapor into the air. So again, it's evaporation, condensation, precipitation, and then the Coriolis effect, which I've talked about, or Coriolis effect that I talked about in other videos, is going to push that moisture, latent air masses in certain directions based on your latitude position on the planet. Okay, so now groundwater. Groundwater is actually a big topic for standardized testing. They want you to know about like water tables, zone of saturation, zone of aeration, all that good stuff. All right, the zone of aeration is a permeable layer. Put that in your mind, permeable. Permeable means that water can trickle through it. And in this area right here, we can see water trickling through this area of rock or soil. Some rocks are more forgiving or allows more water to penetrate it and go through it, where other rock just says, nope, cutting you off, you're here. Typically, granite is the one that cuts them off. You're not passing through. You shall not pass. Okay, that's typically on bedrock. The permeable layer here, or the zone of saturation, zone of aeration, might be stuff like karst topography or sandstone, things like that. But shale, granite, those types of things are impermeable and does not let water go through. The water table is the top of the zone of saturation. It's just you dig down, you say you dig down 200 feet, you go, oh, I've reached the water table. I've reached the top of the zone of saturation. Now, the zone of saturation is exactly that. It's just the area that's saturated. It's the area that's saturated by water. And you can see, like in these pictures, like the rocks down there are broken. Remember soil layer A, B, C, and the other concepts I told you. Well, as you go down and down and down, you get to more rock that are more basically together. They're not broken up as much. But we haven't reached that here. They're still broken up and allows the water to trickle through it. So this water is it's moving. It's a moving system. And eventually it moves towards lakes, or it moves towards rivers, or it moves towards the ocean. So it's moving slowly, going through these broken pieces of rock. And it's completely saturated with water. And so that's the zone of saturation. Now, when you get down beneath that, that's where the rock is solid, and that is your bedrock. And no water can penetrate it. No water can go through it. So, and then I already said that's typically like granite or just rocks that are impermeable. They're solid. They don't allow water to trickle through. So that's an impermeable layer, which it says right there. All right, rock types in relation to groundwater. You see there limestone, that would result in karst topography. Sandstone, allowing the water to trickle through. And then shale, slate, granite, those things are impermeable. They don't allow water to trickle through. They're solid. Okay, groundwater sources, aquifers, or artesian wells. You see the aquifer just digs down to one layer beneath the surface. It penetrates into the zone of saturation, where artesian well goes through two of them. And you can see right here that the artesian well went all the way through your first one and then drilled through the bedrock and entered the second layer of groundwater. And that pressure there pushes the water up and lets it come out naturally. It says I reached my time limit. I'm going to have to go ahead and send off this. I might make another one. So I'll see you soon. Thank you for watching. Bye.